While we're waiting for more people to show up, I will remind people that the meeting does not start until we have a volunteer note taker.
One or four.
So you don't have to do the whole day or anything, just volunteer for some portion of the meeting and we'll get a set of people. So did you figure out how to get this going?
Yes, it was.
Okay. And then how do the slides make it up?
They take whatever's on this one.
Oh, wow. Cool.
And they figure out that if you have to do something.
It was just figuring out the UI.
Oh, to tell people, right. Oh, okay.
Did you put it on the wiki also?
I think they did.
On the wiki as well.
Are you doing it?
No, I thought you said you were doing it.
I do bits, I don't do electrons. People are wandering in.
We have roughly the number that's signed up, so even if it's not exactly the same, but good. Not that number. So. Well, we got the coffee now, so coffee is available.
Yeah, no, but we want one break in the morning?
Yes.
Just for the note taking, when you...
Well, it depends on how discussion, but let's, I would say, we're going to 12:30, so I would say coffee break somewhere between 10:30 and 11, whatever is convenient. We have to be careful to use the mic now when we are having remote participation. Are there any mics in the room? No.
So,
Working.
This seems to be working, right?
Yep.
Does this work as well?
Yes.
Yeah, okay. Regarding these mics, we're doing remote participation this time, so whenever you speak, you need to speak into the mic today.
Okay, let's get started. Congratulations for finding the room. That's step one. So this is the Sunday interim for the ICNRG. Before we get any further, we need to have some volunteers to be note takers. What we have done in the past is that we've had 4 people, one to do the first morning session, one to do the second morning session, and then the 2 afternoon sessions. So we really cannot start until we have note takers that will work on the Etherpad. So volunteers for, let's get volunteers. If you volunteer first, you get to pick your session.
Mr. Zito, congratulations. Congrats, you just won the first note-taking session. Oh. Okay.
Well, you pick one. Which one do you want? Want to do the first one? That'll allow us to get going.
Yes. So if you look at on the wiki page, there's a link to an Etherpad. If you just use that one, it would be great, and other people can maybe also support you.
All right. Do we have someone for the second morning session? Come on, folks. It's not that hard. You don't have to, write down everything people say, just the general record of the meeting.
Okay, so I take the second session, but we need 2 more people for the afternoon.
So do the first afternoon session. Then we just need someone for the last afternoon session.
I'll pick the last.
All right. It's usually not good for the chairs to wind up having to do this. So you lose brownie points as RG participants. Well, thanks to the volunteers. I'll quickly introduce the chairs for those of you who don't know us. We've been around a while, so most of you know us. I'm Dave Oran. I'm an independent consultant these days for my company, Network Systems Research and Design. Woodier Ullman from Ericsson, and Dirk Kutcher from Huawei. So this comes up first on every meeting, which is the IPR policy. Please have read it and understand it and don't violate it. I won't read it because it's been there for a long time. Some quick administrative stuff. Just so you have on the record where our mailing list is, where the web page is. We have a wiki which keeps track of constantly what's going on. We have a GitHub repository for working on documents. And that's about it. Now that we have some note takers, I will we'll record the note takers so we can thank them. So here's our agenda for today. Those of you who had a chance to look at on the wiki, it's a reasonably full agenda, but we have some spare time. So the idea here, as we do on most interim meetings, is to be sure we have plenty of time for discussion. So we sort of have general guidelines for how long each piece of the session should take, but we tend not to be terribly rigorous about keeping people to their time. If you take less time, there's more time for other things. So is there any agenda bashing we need to do? Things that have been missed on the agenda, things that are on the agenda that shouldn't be there, modifications?
Just one thing about this, not keeping the time. The intention is not that people should go on with their presentations. It's that we should allow for interesting discussions. That's what we want to have the time for.
So one quick, we need to have a thank you to Ericsson, who's the sponsor for the meeting, providing the coffee and breaks. So thank you, Bourdieu, for arranging that. Ericsson is the overall sponsor for IETF this time, so they deserve our thanks. Okay, let's dig in. Anybody have? Are you at the mic to ask something? Oh, okay. Lovely. Okay, the blue sheets are circulating, so bring them up when they're done. So first on the agenda, Chris Wood on a comparison of security and privacy features in the FIA architectures. And let me get Chris's slides up. Yeah, there you go.
Yes. The camera got you.
Let me make that a little smaller. Should do it. Trying to figure out how to make it full screen.
Commando.
It did nothing.
Yeah. Yep.
This is good enough.
That's fine. Okay, good morning, everyone. My name is Chris Wood. I'm at Apple now. And Gene, my advisor at UCI, kindly asked me to present this paper. Joint work with Moreno, Alberto, Moro, and Cesar on a security and privacy analysis of the NSF future and architectures. Slide, please. So as we all know, security and privacy has been kind of a sad story in IP. It's been really retrofitted on after the fact. Take a look at any number of protocols that are used today, SSH, SSL, TLS, IPsec, and IETF, secure BGP. These are all things that are bolted on after the original protocols were kind of set in stone to try and make the situation a little bit better, and getting them out in the world and adopted has been a challenge in certain respects. And the goal of the FIA architecture and project is really to make this security and privacy kind of a goal from the outset. So the NSF program the NSF FIA program was really just do-zero competition with the major goals of, like I said, generating a candidate or a set of candidate next generation internet architectures that wanted to have security and privacy as a fundamental design instead of something that was bolted on after the fact. There was initially 5 projects that were funded. Those include NDN, Mobility First, XIA, the Expressive Internet Architecture, TraceNet, and Nebula. And only 3 of them advanced to the second round, or second phase rather. Those are NDN, Mobility First, and XIA. And those are the ones I'll focus on in the rest of the talk. And okay. And there's a typo on this slide. So really, I'm just gonna go through a brief overview of each architecture. Most of you are probably familiar with them, and then just talk briefly about the relevant security and privacy properties, including things like trust, data origin authentication, pure entity authentication, and so on, and try to compare and contrast them against IP. Now, I don't claim that comparing against IP is probably the best avenue. IP is an architecture that serves a different purpose than ICNs in general, but that's what we have here, so that's what I'm going with. All right, so starting with NDN, and I guess CCN because they're kind of similar. So if you keep scrolling. So from a security perspective, we all know that integrity and trust, I guess, are properties of the content. So typically every single piece of content comes with a signature. The producer generates a particular signature, and a producer has an identity that the consumer can use to verify the authenticity of the content. And if you want confidentiality, you have to encrypt the content typically, and that's done out of band. It's not a core part of the protocol or the architecture. So with respect to trust, in comparing to IP, we have IPsec, in which trust is placed in the end hosts of the gateways that you want to establish pipe through, whereas in NDN, trust is on the content. You don't care about which particular host it comes from or which router it comes from. So it's a completely different granularity of trust. The channel versus pipe, or the pipe versus the content argument here. Yeah, sure.
Use the mic, Jan.
Does it work?
You can take it out.
So you are comparing to IP, right?
Yes, that's what these slides are doing.
Well, but in reality, a lot
It's not. Maybe I can like predict where you're going. The comparison is not correct against IP. The better comparison would be against something like the entire stack, HTTPS, right?
Right. That's what I'm saying, because
Yeah.
you know, with ICN, you have a mix content and routing.
Yep.
You all know that, right? But in reality, you don't often have IPsec counters when people retrieve content from the right? IPsec is more what VPNs can do.
Do not disagree.
So you always, the whole study only compares to IPsec, or?
It mostly focuses on IP. They kind of took the approach that, well, they're going to replace layer 3 and up, so let's just compare against layer 2. That's not the right functional abstraction. I agree. Yeah, thank you. So with respect to data origin authentication, because you're just not me.
So good morning.
Everybody wait.
In IPsec, you're just encrypting data as it goes over a particular tunnel, so the trust ends there, and the data origin authenticity ends there. You can only guarantee that the data came from the other end of the pipe, whereas in the end, you have complete trust that the content came from the producer who originally generated the content, no matter where that particular content happens to be served from the network. Next slide, please. So pure entity authentication, something else they considered during the establishment of the Secure Association IPsec. You simply just authenticate your peer as a natural or necessary part of the protocol, whereas in NDN, they claim it's not available. The notion of a peer is not really applicable to NDN anyways. There's content, not hosts. Although they say that assigned interest can kind of help authenticate consumers in particular applications. Like if you wanted to execute an RPC, buy an interest or something like that, maybe you assign the interest so that the producer who receives it can verify it for whatever purpose. With respect to authorization and access control, this is kind of this is making my Jan's point a bit stronger here. In IP, there's no access control or anything that happens on content at that particular layer, whereas in NDN, access control is directly applied to the content if it is applied at all, and mainly through encryption. Next slide, please. In availability, in IP, it's a bit easier to deplete bandwidth and spoof addresses and many other kind of network layer attacks, whereas in NDN, this bandwidth depletion attacks are much harder, particularly because you have suppression via bits and suppression via caches, although the latter can be bypassed. In general, NDN favors better here. And there are many known attacks on NDN and CCN in general, and the router resource exhaustion attack is widely known, and there are no concrete solutions yet. There are approaches that have various trade-offs, and there are also cache-related attacks, which I would also claim is kind of a resource exhaustion attack in a way. Those include content poisoning and cache poisoning, one of which is not so severe, and the other which is pretty detrimental. Next slide, please. All right, mobility first. So there's an overview on the next slide. So mobility first is an interesting type of architecture. It's built on top of, well, it's an overlay architecture built on top of IP, if I'm not mistaken. So you have a data plane that routes based on several different headers in a particular packet, a GUID, a globally unique identifier, service identifier, and these flat network addresses. And you, on top of this, or to get information to route packets, you have this global name resolution service, which is the backbone to essentially the entire architecture. And every single name of a particular content is associated with a globally unique identifier. So if someone wants to inject data into the network such that it can be reachable by someone, they have to first register the name with a name certification service, which goes into the GNRS and updates it and distributes that information around. And then later, when someone wants to resolve or fetch this particular piece of data, they query the GNRS for the or with the globally unique identifier of the thing that they're after, and get back some routing information, essentially slap it on top of the packet, and then send it out and get their response back. Next slide, please. So just like before, with trust, IPsec, we have again, the end hosts are trusted. The mobility first, the trust is on the hosts, the content, and the services that are involved. Additionally, you have this notion that the global unique identifiers are self-certifying in the sense that they're derived from the names themselves. Typically, it's the hash of the thing, the principle, I guess, that they're referring to, so that it increases trust in the way. So I'd say.
Yeah. Jan again, I have another comment. I'm a big fan of self-certifying names, but the saying here is also not entirely correct, right? Self-certifying names for GUID makes it easy to achieve here at the definition of PKI. Right, you always need to know that you always need to have a trustworthy source where you get the self-certifying name from, right?
Mm-hmm.
So you're just pushing the problem to another layer. It doesn't really solve the problem.
That's right.
Okay. Just wanted to make that clear.
Thank you.
Yeah, because it sounds there that, like it's different or better.
I should have like big slides. I am not the creator of these slides. And just a
Sorry,
humble
you're the messenger, and we are going to criticize the messenger here. It's sorry.
I know.
That's the way it will be now for the next 20 minutes or whatever. Or maybe you can convey the feedback from.
I will.
I guess that's
surely.
the goal, right? Please go to Gene and whatever.
I will make sure he knows for sure. Right. So next slide, please. So with respect to data integrity, again, we have it just in IPsec, applies to data in the pipes, that's it. And mobility first, it applies only to content principles, not service principles. And the way we get it is that the GUID is the hash of the content in question. And then with respect to all the other properties, essentially there's no other difference between mobility first and IP. Yeah. Next slide, please. And there are various attacks on mobility first. I guess that one general one is that the GNRS is not secure. You can have an adversary inject any kind of information into it, particularly these orphan mappings where these names don't map to anything. That's not great. You have the late finding problem, in which case you inject something into a GNRS and then the time to propagate that throughout the network introduces a delay that could potentially DOS certain routers or certain consumers or users of the network. And then there's this this QID to network address mapping problem, where an adversary can send a packet with a header that does not have the correct mapping between the GID and the network address, and the destination router who's trying to route that will have to query the GNRS to actually get the mapping. So you can enforce a router or routers to do this query resolution, and that's not so great. All right, and XIA is the last one we're going to talk about. So the motivation for XIA is that the current internet pretty much focuses on a single principle, and communication with pretty much any more than one other endpoint introduces a lot of complexity, and this is just because of the internet architecture is a point-to-point, or the IP-based internet architecture is point-to-point, and not really scalable or amenable to multi-party conversations. And so the XIA approach is to make the network architecture more expressive in a way, in that different types of services can be more easily supported instead of just point-to-point communication between two hosts. You can have, but you can still have this kind of host-based communication. You can have service-centric network communication. You can have content-centric communication, any type of X-centric or N-centric, whatever type of feature in the network supported by the architecture. And it's fairly loose in what type of features you can, I guess, build in. And that's one of the major goals. Next slide, please. So some of the design requirements, first of all, that users and applications would be able to express their intent, and that any intent should be supported. This would be an intent to offer a particular service, an intent to service up some particular piece of content or some set of content. And the principal types must be able to evolve over time. That means that if you want to add new principles to the network, it should be easy. Principle here is like a service or content. And network adaptation should be incremental, as is good design. They want also the principal identifiers to be intrinsically secure, so that you don't have to rely on some kind of external entity to authenticate them. And this means like deriving any type of binding information from the whatever you have, whatever piece of data you have about the principal at that time. So, for example, deriving a principal ID from like a public key or something like that. So that please. So with regards to design requirements, in order to make XIA work, you have to define several things. First of which is what the semantics of communicating with particular type of principal are. So that means that host-based communication, a host-to-host communication is not the same as host-to-service or host-to-content. There are different ways you communicate with different principals. And so the architecture needs to support these different varying modes of communication. And in order to do that, every single principal ID has to have a unique so-called XID. So a host will have a unique host ID, service will have a unique service ID, and so on. And you need a way to kind of generate these IDs and then map them to whatever intrinsic security properties you want. And as with all the FI architectures, we want in-network processing, routing packets. That's pretty much the main goal of the project, one of the main goals. So in the data plane, you can, well, the data plane is basically comprised of this XIA, or Expressive Internet Protocol architecture, and that defines what the headers look like and what packets look like and what processing each particular node or hop needs to do. So typically when a consumer or a client, a sender of data transmits a particular packet, they'll inject an XIP address, which is this basically a DAG that specifies where in the network this particular packet should go, how the next hop should process this particular packet, and all of these things can be used to either route that particular packet to a service that can potentially handle the data or the packet, or a content host that could, or content principal that could potentially handle the packet, and so on. And the format or the semantics of that particular header depend on the type of principal with which you're communicating. So if it's just a host that you're communicating with, you might just have, a very short DAG in which contains the address of the other host that you're talking to. If it's a content, or if you're communicating with a content principal, you might have the content ID in that particular packet, and a processing node might use that content ID to look up in its local cache whether or not it has the particular piece of data before forwarding it onwards. So the semantics of how you process a particular piece of packet depend on what routing information is available in the XIA or the XIP header. And yeah. Next slide, please. So as I said, there's a number of different principles. There's hosts, network, and services. The IDs of all of these are self-certifying in the sense that there are always hashes of these public keys associated with each of these services. Host IDs are constant regardless of the host network. It's an intrinsic property of the host. Network IDs can they point to a collection of hosts, and a service is kind of similar to a destination port associated with a particular IP address, and you might denote a destination address of a service, identifying a network ID, a host ID, and then a service ID, much like we do today. Next slide, please. And you also have content principals, in which the content that is the principal here has an ID, which is the hash of the content. Without going, I guess, into any more details, when processing these particular packets, all routers, or to actually support all these different types of services, every single router must be able to process these network IDs and these host IDs to route across different networks and to route to particular hosts. Content IDs and service IDs are really properties that kind of exist within hosts. Processing of any other non-network ID or host ID is a service that more specialized, I guess, routers can do. So, for example, if you have a caching router, it should probably be able to handle caching or content IDs, but it's not a requirement. All you need to be able to do to route packets is to support just basic two, the network ID and host ID. Yeah.
So, quick question here. Since the IDs here are effectively flat, you need some way to translate that to get the DAG that includes the NIDs and the HIDs of a path to that thing, right? And what performs that magic?
I don't know, actually. I don't know that particular detail. Does anyone here happen to know that about XIA? How the DAG is actually discovered?
Okay. I think I do, because I did a lot of work on XIA a while ago, but it punts to the control plane for routing things that are done in the forwarding plane on some of the other ICN, some of the ICN direct architectures. So it's much more like a source routing approach to routing. Okay, thank you.
Next slide, please. Okay, and then going back to our typical comparison, In XIA, we use CIAN, the CIAN architecture for trusted path selection. And CIAN's architecture allows for, let's say, control isolation for secure, available end-to-end communication. I don't know the details of CIAN, so I can't go into any more specifics there. With respect to data origin authentication and peer entity authentication, IPsec, said numerous times, provides these particular features, whereas in XIA it's not provided by design, but you have essentially self-certifying names or self-certifying identifiers that are derived from all these public keys floating around. That can give you some notion of authentication. Next slide, please. Integrity, IPsec, said it many times. And XIA, integrity is kind of only available for the content principles because the content ID is the hash of the content itself. And integrity of a service principal or any of the principles is referred to the application. And then with respect to access control and authorization, it's basically a combination of IP and NDN, although I don't know what they mean by a combination of IP and NDN. Content principle, well, I'm not going to talk about that because these particular bullets don't make much sense to me. There's no access control on IP, so moving on. Availability, it's very easy to deplete bandwidth just like it is in IP. If you have a valid DAG, you can essentially send any packet and force any kind of computation that's expected. But attacking cache is a bit more difficult because every particular piece of content has a self-certifying name, so it's very easy for a router to know whether or not it's caching a valid packet or not. And then anonymous, with respect to anonymous communication, which is something that was not brought up earlier in the other two architectures, you can get it by using, or an IP, you can get anonymous communication using Tor, or pseudo-anonymous communication, depending on how paranoid you are. And there's no, I mean, you could do something very similar in XA. You could build a Tor-like service similar to the Andana service for NDN and CCN. And that's pretty much the best you can do at that point. Next slide, please. And then here is their helpful little table that shows you exactly what properties each particular architecture has. And it has a column for Nebula, which is an architecture I did not discuss. The check mark means yes, it has it, great. X means no, and the circle means eh. What's up? Yeah. And that's it. So I will, Jan, I'll make sure to relay your concern, Sam. I also echoed the same kind of thing to him previously, but it was not well received. Well, I'm the lowly grad student, so.
So can you share with us a little bit about the motivation for why they did this? Like, what's next? So,
well,
is the intent to like propose some Uber something that is?
No, I think it was primarily out of curiosity. They just wanted to answer some of these kind of lingering questions as to, how does one compare to the other? But I don't think there is a next step in this particular analysis, particularly because all the folks involved, Modular Gene, are now seem to be kind of moving past ICN.
We're hoping to work with Moreno, who was Mauro's.
Oh, okay. So I don't maintain contact
Okay.
with him. So if he's still involved, great. I know that like Cesar in particular has moved on, and other. I don't know how much of an interest Mauro still maintains in ICN, but hopefully there's more work to be done.
One quick question here first. You don't have the IP column there. How would that look?
A lot of X's, pretty much, because there's no security in IP whatsoever. If you were to kind of talk about IPsec, you would have things like data origin authentication. There would be, most of them would be circles, pretty much, because it depends on how you define it.
Okay.
The origin of the data is the other gateway that sends something, or.
But it's a good question from Brian. I was going to say the same thing. If you were having IPsec here, you still a bit misleading because the actual problem is not always like what property can you theory achieve, but it's more about key management, trust management. Those are the real issues actually. Also, the ICN community is discussing. I guess so it's not so much about I can sign content, I can equip content, all of that is out there, and it's more about management or service infrastructure, how reality would really look like. And another comment I have is availability seems to be like an unsolved issue if you look at it, right?
Yes.
But that seems kind of strange to me too, because actually ICN, the content is available it's spread all around the network. So actually, as an attacker, I would not even know where the content is. I mean, if somebody hosts a server and has the content, it's very easy for me to target that server, and we all know this, right? It's really not a solution. Nice, yeah. And arguably, the content can be anywhere. It's distributed, it's cached everywhere, so availability should be much higher.
Yep, I don't disagree either.
I'm just saying.
There's the inverse problem that I think we in this community don't like to talk about very much.
What problem?
The inverse problem, which is ensuring something is not available. Right? The ability to deterministically forget with the barrier synchronization basically doesn't exist in a lot of these architectures. So I don't, tick that off as just a sort of a, out of left field kind of, don't forget, availability is a two-edged sword, right? Sometimes you want things to not be available.
That's also true for today's internet, by the way.
Anybody can spread any kind of
Once it's out there, you can never get rid of it.
I think I'm here to interrupt you. With this internet, you can catch anything for anything. There's no authority over the area. But also, I want to second what Jan said. At least from our years of the last few years of the most difficult thing is actually to manage the costs. I think that that is the valuation dimension. I think when you type in the names to be able to actually describe your policy and distribute the policy just like a bag of bits, but on the other medium data, make it manage the difference.
Of course, yeah, I agree.
So
Yes.
I think that should be either the one important criteria in this.
The trust is very vague here. Yes. The trust net.
Enabling the customers.
Yes. Thank you.
So one question on basically all these architectures fundamentally have a source ID in the pattern, right? And I think that's
A source ID?
you have source and destination ID, like who is asking for something or
NDN has no source ID.
not Indian, I would say.
Okay. All right.
So I mean, that's a better way to handle things like authorization, access control, and accountability. So I'm just wondering why you have put they're not supported in these architectures.
Because they can be spoofed, and that's not really something you want to do or enforce access control on.
See, when you have a source ID, you can authenticate the person who's asking for it right at the edges of the network. So spoofing, I mean, how?
But you don't enforce access control based on where it comes from in the network. That's not
No,
the
so
thing.
when the user is actually connecting to the network, right, you can actually authenticate the particular user. So that's where probably what Jan was asking about mobility first. On
But
basically,
you just said you authenticate the user, not the source address, right?
no,
authentication
ID is basically based on the ID, and the ID has a trust component to it, right? So I mean, if somebody is asking for something and you want to give a content to him, you can always authenticate, saying that okay, is this a person who is authenticated to get the content or not? Right?
So this is a really interesting topic. I'm not sure we want to delve too deeply into it because the purpose of source addresses in most of these architectures is for reflexivity, not for authorization.
No, but
Right, and certainly none of these architectures actually provide separation of the reflexivity property from the origin authorization part of it. Right, you need something like AIP or or one of those types of approaches to do that. So basically there's a problem if you attempt to use these source IDs for authorization.
I mean, at least I know about mobility first. It's basically they have proposals where you can fundamentally have a state for devices connecting to the base station and authorize them. So that fundamentally takes away a lot of the control plane that you use for today's access control in things like LTE and stuff. Right? I mean, you can have a flat network without having specialized control plane like doing to the MOVs and stuff, rather than you do it at the base station itself. I mean, that's a very powerful. So when you talk about network security, that's the feature you want to have.
Right, but the downside of that is that you've bound two pieces of trust together that should probably be disentangled. Right, which is the trust you have in the forwarding to send it to the right place and get your data back, from the assertion that you are a legitimate requester or receiver of data. Have you ever read the AIP paper? You really ought to.
Not the AIP, but I was talking more from mobility first time.
Right. I think mobility first actually keeps those two things separate as well, because the GIDs that are used for as source things are not the same ones that are used for authorization to connect.
As far as I know, that's right.
Yeah, they're actually different. Now they may use the same data structure, but they're actually separate instances of that item.
Yeah, they're separate.
Yeah, so you're actually not using the authorization, source authorization during the transport to decide what's legitimate and not.
So, I mean, this is assuming that, again, the applications themselves might get their IDs from a different context. And, but if you basically have the transport IDs and the application level IDs somewhere have the same IDs, then it serves. I think that's what they have in mind. So when applications are asking for an ID, then basically using the source ID serves for the applications as well as the transport ID. I mean, so I was just, because that's some of the selling points they mentioned in their architecture. So,
Okay, I'll have to look into it.
All right, think we're done. Thank you.
Yeah.
Well, we can give you the dongle and you can do it.
Yeah.
Yeah, I think we should do that.
Yeah.
Okay. Good morning, everybody. So my name is Luca Muscariello, and I work as a principal engineer in Cisco. And so here I'm going to talk about a new project, an open source project that we have recently launched in the Linux Foundation, which is called Community Information Centric Networking. Before going into that, there are some assumptions that I think you need to be aware that are very much related to this research group, but also to the open source project, which is related to some recent actions made by Cisco on this topic. The first one is about Cisco acquisition of Park CICN technology. The second one, so the open source, that I'll go through in more detail. And the third one related to ICN adoption is related to a technology that we are developing in Cisco, which is called hybrid ICN. So about Cisco CCN acquisition, the first question is what changes really? So for the IETF and IETF in general, if a working group is created, there are some IPR clauses which are related to the current CCN draft adopted by the working group, which are very different to the previous IPR clauses as published by parts before. So being Cisco the owner of the IPR right now, so we have changed. You can see it on the website. We have changed the statement that gives you grant access to the IPR if a standard is adopted, and with a reciprocity clause, which is the standard Cisco IPR strategy at IETF. It's exactly the same. Which means that all the IPR give you basically, so Cisco will not assert any patents against any party for making, using a product or selling a product when using this IPR, if the product implements the standard, okay? And also Cisco reciprocity, Cisco retains the right to assert its patents against any party that asserts a patent its own or control against Cisco in any IETF standard.
Let me just make a comment here. We probably need to verify this because I no longer work for Cisco, but I believe that this IPR statement covers experimental RFCs as well as proposed standard RFCs. So it doesn't necessarily mean that you're not covered at any point before the IETF adopts it as a full IETF standard. So we can double check that, but I remember back from my days when I was at Cisco that we worked, since we knew there would be a bunch of experimental RFCs coming out of this work, that we wanted to make sure that any Cisco IPR applied to experimental RFCs as well. So that says that if anybody wants to contribute their work through the ICNRG to become an experimental RFC, then even if it's not this particular code base, for example, then that IPR should be covered, right?
Okay, we can check that.
Yeah, I double check it, but this is a big change, and I think it shouldn't be underestimated.
Okay, next. So this clearly, as Dave is saying, so it's a big change for the IPR management in this framework. And so the roadmap is, of course, to move forward with current draft towards experimental RFCs, or we wish to move forward in that direction. And of course, it's also a new starting point, so it's not the end of the story. It's on the contrary, it's a new starting point to involve other partners in contributing in these efforts. And so, of course, the starting point means to work, so together. Which means improving the current draft and with consensus also plan IETF working group in the future. Okay, let's go through the open source project, which is something that is running inside the Linux Foundation in the framework of the FIDO project or Fast Data IO. So the FIDO charter is about supporting data plane, highly performant data plane packet processing in software, using all the most recent technologies for doing high-speed packet processing in software like Intel DPDK, Cisco VPP, but also isolation technologies like Linux containers, plus all the other technologies like orchestration and management of virtualized resources. So focusing more on the CICN project, so for community ICN project. So we have open sourced recently several software components, which include a VPP ICN for water, which is compliant with the CCNX 1.0 draft specifications, if they are published right now. We also open source a socket-based for water, which is the previous Sparks Metis for water that we improved in terms of performance, but it's exactly the same code base that it was released under the BSD license before by Park. We also have released a new ICN socket API, which is a middleware. It's a library that is supposed to provide an API for applications. an HTTP server, which is able to use the ICN socket plus the standard TCP socket to do to deploy HTTP. We also open source a Dash video player, and to conclude, we open source also what we call the ICN, which is a framework that is able to use most recent virtualization technologies plus orchestration and management for deploying ICN network inside Linux containers. All the software is being distributed under Apache 2.0 license. So more in detail about every single software package. First of all, so the packet processing you can have in the Linux kernel is highly limited by the fact that the Linux kernel is a general purpose operating system. So you have I/O limitations plus also limitation related to the way the Linux kernel makes use of the cores available in the compute machine. And this is where VPP, so vector packet processing, really helps in improving the usage of your general purpose CPU cores. And it is also a framework that allows user space packet processing, bypassing operating system I/O limitations. And this is in line with all the flourishing projects about doing packet processing user space like DPDK, NEPA, OpenFastPath, and others. VPP, it can exploit all the DPDK acceleration, but it can also use other drivers for interconnections. Like you can interconnect many other kind of drivers to VPP, like AF packet interfaces and shared memories and others and other things. So it's a more general framework for doing packet processing in the user space. But of course, when it ends up to having the best performance in terms of packet processing, there's a lot of work done in using DPDK accelerations, where you get all the benefits from the line card to the cores. So the CICN module for VPP, it's a loadable plugin written in C that it implements the core design that is that was published in ANCS in 2013, and it is currently using adjacency, ICN adjacency based on the FIT tuple, so IP and port source destination address, IP source destination addresses, and port source destinations, and UDP protocol. So we're using an IP UDP encapsulation to implement an adjacency. The current performance is measured in around 1 million packet per second per core, so which is more or less around for Ethernet 1500 bytes MTUs, it's around 5 gigabit per second throughput. And can use both DPDK driver and AF packet currently, so you can use a DPDK for line card interconnection. You can use also AF packet drivers for other things like interconnecting applications to the forwarder, like transport protocol in a server, typically. But also to interconnect other kind of forwarders that I explain later. So this is an example of interconnection of the VPP forwarding to other socket-based forwarders like Metis, as I was saying. So by using an AF packet driver, you can run the Metis forwarder, which is written in C99. You can run it. You can interconnect to the high-speed forwarder using AF packet interfaces or VPP bridges. Which is, well, advertisement, which is something you cannot do, for instance, using Open the Switch. So, so the VPP switch can allow you to interconnect a number of different drivers, not just one. So you have a wide range of interconnection possibility you can have using VPP that you cannot have otherwise. So the Metis forwarder is currently limited in throughput, but it's highly portable. So you can build this kind of forwarder in many platforms, especially for end devices. And we are currently, we're going to open source these days Android SDK for doing that. But we have also a proof of concept for iOS, and it works already in macOS, Windows, Linux, basically all the end devices and operating system available. So throughput is limited to 300 megabit per second with usual MTU, as I mentioned. But it's something that can be improved in the future, but it's good enough for the application we are targeting for the moment. So the ICN socket API is another piece of software. It's a library. Everything, as I said, is running in user space. It's a library that is running on top of Metis and the VPP ICN plugin. It is based on, it implements a number of things in the transport, including reliable transport. It gives a consumer producer API to the applications. It implements a layer 4 manifest and all the other services you expect to see in a layer 4 service, like segmentation and reassembly. The segmentation in ICN on the producer side also assumes all the signing process. It implements reliable transport, but also interest flow control in the consumer side. It implements also congestion control for loss recovery and congestion management. It also implements a mechanism like remote adaptive active queue management in the consumers. So the design is based on recent publications in the area. The HTTP server is another piece of software that we have open source. So for instance, you're not going to find any, let's say, in the software distribution, any ICN content repository. You won't find it. We made this choice because we wanted to use an approach which is closer to current way of managing application and distributing content. So basically using an HTTP server, which means that you have a socket that is able to do all the publication on the fly with a backend cache, which acts as a online content repository, but it's transparent to the application developer. So you don't need to do that yourself. It can use, so this server can use an ICN socket, but also a TCP socket, and it currently implements the HTTP GET method only, and we are working on the POST method and to be published soon.
Hi, Jan Zidov again, Luca. I think Dave presented a couple ICN energy meetings here, and you or somebody else from Cisco presented that you did some work on looking at HTTP over ICN. It's difficult, right? The whole Web 2.0 Ajax thing. So you are basically having here an HTTP over ICN solution, right?
So let me characterize it. Doing the web over ICN is difficult.
Correct.
Right? Some of that is due to the way the HTTP protocol works, but some of it isn't due to that. It's due to how applications use the HTTP protocol. So I think this addresses part of the former, but not the latter. I mean, this is not going to deal with, you know, an accept content HTTP header that says, you know, pick one of 17 languages, and it's not going to handle cookies, you know, or any of that kind of stuff. So I don't want to step in, but I suspect that this is a very basic kind of thing. You do a get of the equivalent of a URI. There aren't any of these zillion HTTP headers in there that the server's supposed to do something with. Right?
Yeah, that's correct. So the paper you were mentioning is really about implementing a RESTful communication model on top of ICN, which includes many of the things that Dave is mentioning, like how do you implement stateless, how do you manage all the stateless features you have when you use HTTP, overloading a little bit, probably, you know, some of the specification in the HTTP protocol, but it's really about the RESTful communication model. We are not addressing all those questions. We are mostly focusing on some of the methods in HTTP, especially the GET one, and also the POST, but we're not focusing on other headers in HTTP, like some of that they mentioned, where you can enrich a lot. So, but
I mean, thanks for the clarification. That actually helped a lot in my mind. But I think I'm still not 100% clear of how HTTP and ICN really relate. Right? In theory, you can do everything without HTTP. right? So are you doing this for backwards compatibility or, yeah, I guess that's the main point, right? If someone has an HTTP client and now, well, we would still need to support ICN, right? Or,
I'm not sure, I know, maybe you're asking many questions at the same time, but let's say HTTP is using a TCP socket today as a pipe to transfer some information from one point to another, and then you implement a communication model on top of this byte pipe. Now, what we are doing here is it's not doing everything we can do today with HTTP, but it's more, what would you do if you had an HTTP, an ICN socket available into an HTTP application, and how would you map what we're currently doing into it? So we have made this first step for the GET. We also made a step for the POST, but there are a huge number of headers in HTTP that we didn't consider yet, like what would be the equivalent? Because at the same time, what we are trying to do here is we have a new socket, because it's not trivial to map an HTTP communication model into TCP IP neither. So you need to do it. You need to design a way to do that. And today it's just you have a byte pipe. You go from A to B and you transfer information from A to B, and you let the web process on the other side to process all this information. While here the question is more if you have an ICN socket with new services, because it's not anymore just a byte pipe, how would you map HTTP, the GET method, for instance, into ICN so that you get advantage of the new features? But it's the first step. Then a question could be, just considering all the other headers, what would be the advantages you get from an ICN socket, and how would you map these headers or these services into an ICN socket? How would you, it requires work. Like otherwise, you end up having just another byte pipe from A to B, and you don't get all the features and advantages like you can have potentially. But it's not trivial. Even for the POST, it's not that trivial to do the mapping. So, for instance, you can do some kind of reverse pool, or you can do other things, but it requires some thinking and design.
Thanks a lot for the explanation, and it's a lot clearer to me now. I don't want to take up too much time, but it's still for me like if you don't have this whole RESTful stuff, that if you're not supporting that, let's say you want to do video streaming, do you need HTTP at all, or can you do it in a different way? I mean, I guess I'm still asking the why, but I mean, you gave a lot of reasons. For sure, it's interesting to look into it, right?
In the case of, for instance, adaptive streaming, ADR video, you still need an application on top of your transport, and there are many application level problems you need to solve for the video application that you cannot delegate to the transport. So yes, from my point of view, you still need HTTP because it's providing a number of services that you cannot really fix or provide using the transport only.
The research question actually, and this is a research group, is do you need HTTP or do you need something different for ICN, or I don't know. But you're investigating this, so I'm for sure it's valid research.
So the approach is let's see what we have already. Don't try to destroy HTTP, but let's see if we can get something new and maybe working better out of HTTP, because HTTP is a pretty good protocol. I mean, it's doing a lot of stuff, and we have more or less 90% of the application running on top of HTTP. So probably I would keep HTTP. I would probably try to think about what new things I can give to HTTP when you have an ICN socket.
Okay.
And the last component is Viper, which is a video player, which is implementing a Dash-compatible HTTP application. It's composed of a backend and front end. The front end is developed on QML, and the backend is in C++. It implements already several rate adaptation logics. Some of them are mentioned there, and it's using the ICN socket, also TCP. So the backend can switch from, say, some downloading segments can switch from one socket to the other, because you open a socket, you download an HTTP video segment, and you can switch to another socket if you want, even if it's not a good idea. But in principle, it's highly flexible. And it supports Android, Mac OS, Linux, and also iOS is ongoing. So the last component is VICN, which is which is a piece of software that is that includes a number of modules. In the design principles behind VICN are related to scalability, modularity, performance, but also distributed computing and centralized control. It's a piece of software that is taking advantage of Linux containers for virtualization isolations of the compute. Is also using Open vSwitch, VPP, OpenFlow for the isolation and traffic management of the virtualization of the networking component. It's using for management and orchestration LXD, and it implements an orchestrator that is resource aware, implementing also reconciliations, which means that if you have a number of resources that are described using typical JSON model, with JSON syntax to describe your model, it allows also to interconnect the different resources. I'll show you an example of that, but it allows to interconnect the resources, but also to synchronize the resources, and it implements also reliability, like there is one resource that is down, and then the network adapts to this kind of a phenomenon, and the management and the orchestration is centralized. So VICN is an entity that runs in a central locations, but it can also interconnect to other VICN instances if you want to, for instance, federate interconnection of different testbeds. But can also be used for actually running real networks. We are currently using it to deploy networks for demonstrations, but also experimentations, but it can also be done to deploy stable networks. Right, this is more or less all. I'll go through the details of a VICN later, but just a few words about the hybrid ICN, very short, which is an activity at Cisco about deploying ICN inside IP. I'll be very short here. If you're interested, we can talk about this technology, but in very short, you put resource name into IPv6 addresses out of the fields, and it derives data names as a concatenation of layer 3 resource name and layer 4 segmentation information. Okay, so the architecture defines an interest IP packet and a name data IP packet, and for some specific nodes, the HICN nodes, it implements an IP packet cache. So basically it implements an interest data cache, the peak content store, where you can imagine how it works, but it implements routing symmetry in a partial way, so that you have a local flow balance, which is guaranteed only egress interface of the router, while a legacy IP router does not. So you can have hybrid interconnection of the different entities. So also the HICN transport, similar to the socket API we have developed for the ICN open source project. It's a socket API that is using TCP encapsulation and implements the semantics of a consumer producer socket API just as taken from ICN.
So let me just interject something based on the conversation we had, which is read literally the words TCP encapsulation. It isn't TCP. It's enough of TCP to convince middle boxes that it's TCP, but it's not the TCP state machine.
Yeah, that's correct. For the clients, we are using an approach which is similar to a VPN configuration, so that you can enable HICN networking in a relatively simple way. While for the server side, we are using the similar approach for the forwarder, high-speed software forwarder, which is by doing transport in user space and in a scalable way using VPP. So there's a POC currently under development and testing at Cisco and also other partners.
More questions?
Yeah, question, Thomas, a question about this hybrid ICN. Where is this targeting at? I mean, if I understand correctly, when you do end-to-end transport, I mean, it's not TCP.
Yeah, look at him, not me.
But you do an end-to-end signal. And I was just curious, what is the targeting?
I'm not sure I get the, I almost got the question. Can you clarify a little bit the question?
Well, the question is, where are you heading at? I mean, this is,
Okay.
I mean, this is, if I get
Broadly.
this right, this is an end-node to end-node paradigm, so it is not what one of the core things of ICN was designed for, which is not that, but I'm asking where you going.
What we're doing is we are enabling the full ICN features, all the features. It's not end-to-end in the sense, if I understand what you're saying, end-to-end in the sense session-based, like point-to-point. Is that what you meant with end-to-end, like point-to-point?
Well, if you do TCP signaling between TCP end states between end nodes, then it is sort of it's an end
Okay.
between nodes.
So the question is, can you give me more details about how you're doing ICN using TCP? But we can discuss all.
Well, I only know what you have to.
Yeah, the answer is no. We're not. We're doing. We're not doing. We're not trading off ICN by using TCP encapsulation. So we are not losing ICN features by using TCP encapsulation. So we get all the features, like we get multi-point to multi-point. So I don't know if this is the question you were asking.
No, the question is, where are you going?
Well, going is we want to have a very short-term adoption of the technology. When I say very short, that means that we are working with customers so that they can have the opportunity to deploy this kind of technology for their current services. This is the broad. Yes. So this is where we are heading. Then the details, okay, we can discover the details, but we're not giving up about all the advantages of ICN. So we want to keep them.
So one question is on the hybrid ICN thing. So is the goal that you don't want to use an overlay control plane, you want to use the same IP's control plane to manage ICN interconnection and IP's interconnection? Is that the goal?
The goal is to not to run as an overlay because we lose something if we run an overlay. The goal is to have to exploit as much IP infrastructure as we can without giving up ICN features. So the effort we've made in Cisco was related to can we use IP with, of course, we need to do some work because it's not for free. So we need to have new functions in the network to do that. Plus in the endpoints so that the application can get advantage of it. But we don't want to lose ICN features like the multicast, multi-point, security features, et cetera, et cetera.
So then, I mean, because IP would primarily treat those destinations as some kind of unicast. I mean, even if you have multiple places, I mean, it does ICMP, but it's not guaranteed it might go. So you might end up hitting caches where the content is not there. Or because I assume that there is you're taking some name prefix and putting it into your IP.
Okay, so your question is, can you tell me more about how it works?
How do you map the ICN names into IP?
Well, we can discuss about that. But yeah, your question is really about. Can you tell me more about how you're doing that?
How do you do it in a way that it works?
What I can tell you is that we are doing it in a way that it works. We have a prototype and proof of concept that shows. So we are learning a lot by now for the first time using IP. And what I can tell you as an engineer is I was really surprised to see how much we can reuse in TCP IP to get something that is very close to ICN. So it's really exciting technology. The question is now where we can go in terms of adoption, like with people that are really interested in deploying this in the short term. But we can discuss, I mean, about the details.
The other question is that because you have many, your intention is to involve other partners and all. So exactly, other than Cisco, who else is involved in this work?
I'm not sure I got the question. What is the question?
You put it as an open source, and you are seeking collaborators and.
Yeah. So the whole purpose of the community ICN work is really to be a community-driven effort with a strong partnership with the ICNRG and IETF in the future, so people can find a place where you not only put new ideas and new protocols like ICNRG and the IETF in the future, but also you can experiment with software where you can have your idea implemented and tested if you have also the resources to test them. But the community component is very important. It's not just a Cisco project. It's community. If you look at the Linux Foundation Charter, you will see that it's vendor neutral, and it's really made so that the governance is built in a way that everybody can really contribute to the project, and also the licenses of the software is made in a way that every partner is comfortable in working in this open source project.
It's Ralph Bruns. Is there more documentation on HICN in the community community wiki community website someplace?
No.
Okay, that would be really interesting because I would be really interested to hear about how this is better than an overlay. You said that it is. It doesn't seem obvious to me. So I'd love
yeah, it's a question of time. We spend a lot it's a question of time. It's gonna happen. We are because we are putting a lot of resources on the CICN open source project. There are a lot of things that are not yet running in an optimal way, but we're willing to have more documentation and information. So it's gonna be there in the future.
Could you say anything about when that future will come?
I'll give you an answer. It's a community-driven project. So if you can put resources in the project, like if Ericsson can help, probably you're going to have much less load at Cisco, so that we're going to be much faster in providing that kind of information.
Okay. Thank you.
Great. Don't go away. You have the next call.
Okay. Yeah. Yeah, you should bring your thing.
Oh, yeah, absolutely. Here's the
thing.
Here's the thing.
Get some ice.
I'm not sure how far it goes from here.
Okay, so this is a short presentation about some of the work we are doing on building test beds. There is some activities running in the ICN 2020 project, which is a project funded by European Commission and Japan research agencies. But also some activities that are in place in the Internet 2 framework. So the objective is to deploy ICN testbed with federation across the world with a focus on performance. So the objective is to build an high-speed backbone that cover multiple countries with starting from the US, Europe, and Japan. But in principle, anybody could join this effort by providing resources. This is also very much related to the software, open source software, CICN. So the plan is to deploy testbeds. Can be multiple testbeds using virtualization technologies, of course, related to the ICN component. But this is the global objective of the project. So we have several partners. So I mentioned ICN 2020, which includes a number of universities in Europe, also Ericsson and other partners in Japan, KDDI and KKE, and other universities in Japan. Among the partners, I have to mention the Internet 2, of course, but also GEON, who is, which is the sort of a counterpart of Internet 2 in Europe, providing the backbone interconnecting the national internet infrastructure for research and education. And GEON is helping by providing resources in their European POPs so that we can, just like Internet 2, so that we can have compute resources running the CICN software. In the case of Internet 2, we are planning to deploy CICN software in compute unit based on Cisco UCS with the additional component of using Intel DPDK at 10 gig so that people can experiment at higher speed. The software, as I mentioned before, the software is highly scalable. So we have either in terms of data plane, but it's also highly scalable in terms of control plane. So as long as you put resources in this testbed, you can really scale it up in terms of performance. And this will be good also to show the level of maturity of the technology in terms of transport. And this is one of the objectives of the project. So I already mentioned GEON, the GTS project. So we're working with them to make it possible. The ICN 2020 project is a project that has been running for almost 8 months already. So we're going to move now very soon in the deployment phase. So I need to go back to the VICN software because this is going to be a piece of software we're going to be using in this activity to run the different software routers in the different compute units in the US and Europe. And as I said already, so this is using Linux containers. So you just need to have a compute running most recent Linux kernels, operating system in general. It is based on an API using a REST API for hypervisors, SSH, bus, and WebSockets, including monitoring. I'll show you a very short demo later for one very small example. I already mentioned that it's highly scalable and reliable to failures, so that you can run a test bed, the controller will take care about failures. So I'll take a few minutes to go in more detail into these slides, but what you have in VICN is a number of modules, starting from the most from the infrastructure software, which is based on LXC and LXD. But of course, it requires to have a network resource model similar to what you have in Young today, so that your resources are well described in a network model, and they can be synchronized based on the description you give into the network resource model you have developed at the beginning. So if you have made mistakes in your model description, so you cannot blame your software, but it's really a question about having a clear picture about the different resources. When I say resources, a number of things, like it can be a link, a physical link, it can be a DPDK link, it can be also an emulated, well, in this case, it can also be an emulated link, like using Wi-Fi or LTE. But resources can also be other things like bridges, switches, routers, applications, but also services like DNS services or other things if you need it. And it also, one additional thing about the infrastructure, before going to the applications, there are a number of key components which are related to multi-threaded orchestration that make this piece of software scalable, so that you have the different components, especially in the bootstrap phase, to be able to deploy in a highly reliable and quickly. plus all the monitoring, which is something that is managed by the infrastructure component of the software. The other thing is once you have deployed your infrastructure, you have all the ICN routers to deploy, which are also managed by, they're all managed by the ICN component, plus the routing. Currently, the orchestrator is responsible to compute routing and to distribute routing into the network. We also manage routing as a resource in the network resource model, and we already have a number of routing protocols which are centralized. Like you have you take advantage of the resource model in a centralized controller, so you compute the routes based on some things. Of course, with respect to the standard IP routing, here you have a content routing problem to solve, in the sense that you need you typically solve different kind of optimization model with respect to shortest path. So you have typically modification of standard max flow or multi-commodity flow problem, so that you get also the multi-point routing in place. And then the infrastructure will take care about distributing this information to the different nodes. Yeah, so you see also other components that I won't mention in details, but you have traffic management in place. Yeah, the last thing that I want to mention is the application component. So you have you want to use this software to do research, demonstrations in the first place, which means that you require for research especially a number of workloads. So you want to experiment using a network for some applications. So we already have in place a number of workloads like running traffic into the network using different kind of consumers and producers that implement a given application with different traffic characteristics, so that you can do that for congestion management, but also let's say request routing, request forwarding optimizations, load balancing. So everything's already there in place. There is also the wireless component. We are using NS3 emulations for 802.11n and LTE, which is the release just before LTE Advanced. So you're going to get the details. Everything is already open source, so you can get the software there. But in the end, it's going to be for you just a new device in your local container that is implementing Wi-Fi emulation by going through an NS3 emulated process. So this can also be very useful for doing research in the wireless framework. Okay, so how does it work? So this is an example of a very simple network where you have a consumer, one producer, and two access points, one Wi-Fi access point, and one LTE plus EPC single instance, which means that you run in the same node. You run an LTE tower and the evolved packet core in the same node, so that you get basically the downlink and uplink radio channels of LTE, and an uplink IP interface to the producer. So how does it look like when you go into the details? You basically, the only thing you need to do when you start playing with VICN is just working on the description of your network resource model, which is made by using a JSON configuration syntax. So this is the example of the 4 nodes for in a heterogeneous access example. As you can see here, you have a number of resources like a net device, which is a bridge in this case. You have a Linux container, which uses an image, which has something that you can find online, but you can provide your image. We focus on Ubuntu 16.04 operating systems, but then you describe the properties of each resource, like if it's a consumer, it is running in this server. In this case, it's just one server, but it can be multiple server in a cluster. And then you have a category, it's going to be a tablet, and this is typically used for monitoring reasons. And also you can provide a coordinate, like you can place this resource in a 2D plane, but also 3D, but from 2D plane. And this is something that you can do for every single node. You can you replicate the same kind of resource characterization by giving the node different properties. The ICN configuration is very simple. You see here the type is a metis for water instead, for instance, of a BTP for water. And then you tag the node with the identifiers that will be also useful later for identification. And then there's some routing here in place. For instance, on the right-hand side, you see that we are using an ICN routing strategy with the shortest path, which means in this case you have for the ICN component, you see IP routing and ICN routing. ICN routing shortest path means single path. ICN routing shortest path means you run iteratively shortest path, Dijkstra multiple times so that you get multiple solutions on the graph. And then how you deploy and control like the ICN network in this example. For those who are familiar with LXC, Linux containers, you see how we do that. So you run once you have your JSON file, you run the ICN on this JSON file, and then you can run the application into the container, Linux container. In this case, the application would be a producer and one consumer, one in the server and the other one in the client. And then you can also take care about having one or multiple routes. This is how you manage the fact that we give different routes available, statically in this case. I want to be able to connect using Wi-Fi for this prefix, in this case, a web server, or LTE. So this is how we do in this example. This is repetition. Okay, so everything is controlled by using Linux container syntax. So if you are familiar with Linux containers, you will recognize the way this is done. This includes also all the other Linux container management API. But so you can control, verify the state of your container from a compute point of view, but also from a well, when I say compute, means memory, disk, and compute resource of CPU. But also, this is an example about the state of your local networking state, so the connections. But going back to the testbed federation, this would be a very simple way to interconnect various VICN instances in different countries so that they can interconnect and just by having new interconnection domains between the different testbeds. This can be done just by having an adjacency between the testbed.
Thanks. Akbar Rahman, I have a question. The ICNs you showed in the previous slide running over LTE and Wi-Fi, and my question was, do you have any plans in the future to run it over the so-called 5G network slicing? I know that's more in the future and still.
For this software, it's a question of as soon as we have something available, we can insert the module in the software. We have planned to introduce an additional radio access, which is the ZigBee kind of access, but it's for the emulated part, because this is about emulation, of course. It's not a real Wi-Fi access point. You can also have a real Wi-Fi access point if you have a physical machine. This is no problem. So as soon as you have a real Wi-Fi resource in your compute system, it's going to be just a new resource, so you can do that. But if you want emulation, we're using NS3 as an emulation framework. You just need to develop your new radio access into NS3 so that you can get advantage of the emulation. But in principle, if you have a physical device that is plugged into your compute system, you just get it. Like for instance, I was looking at the open air interface project where they are doing a lot of work in having in the same appliance a number of radio interfaces, physical interfaces, even if they are wired, with all the physical in layer 2 processing. Is also something you can plug into the system. You just need to have a card into your server, and that would be an additional feature.
Okay, thank you. That was useful. The one final sort of comment that I had in the back of my mind, I guess, that prompted me to ask the question is because, the so-called 5G network slicing or slicing probably will interact with some protocols like SFC, surface function chaining, and things like that. So I guess my question is, did you have somewhere in your roadmap that you would look at these types of things, or do you think it's too far out and your project timeline doesn't make sense?
So when you talk about 5G slicing, are you talking about the radio split or the backhaul, access and backhaul pieces?
I'm talking about like the high-level concept of network slicing. So it could run through the core and through the RAM, I guess, in the extreme case, or it could be just part of the core network, or it could be just part of the RAM. Theoretically, it could run, from the radio head all the way to where it goes to.
I think that what you're saying about service chaining can happen in the resource model. So you can chain the different resources so that you get what you're saying. Then for the actual virtualization technologies that you use to do slicing, then it depends on which actual virtualization infrastructure you will use in slicing, which is not clear to me. We are basically using Linux container as main compute with virtualization technology, and for networking, basically vSwitch and OpenFlow. But for the radio piece, I guess there are going to be some handles to also manage the slicing piece, which is not clear to me. But I think from a high-level perspective, this is something that will go into the network resource model description, so that you can chain the different services in a meaningful way, so that the flow is properly managed by the slicing. But as far as I know about the 5G slicing effort, all the infrastructure piece is still not specified. So we don't precisely know which are the virtualization infrastructure technologies that will be in place to do what you're saying. So, but from a high-level point of view, that's pretty clear. So
just a related point, there is a barb off this week for network slicing. So, anyways, thank you very much for your answers.
Well, I don't know if that's something, but what I want to show just about showing you how the system works. So we basically have so this is just a control to show you what kind of user experience we have when we're using the ICN. So the typical way we interact with the ICN after we get launched or application network mobilization with the ICN, you basically deploy a network, which is a bunch of containers in like a cluster, which are interconnected properly with the description and normal state, service provided by this container, and then the routing, switching, lots of applications. But this is something that is really related to both of these container infrastructure. You need to be kind of familiar with the container API so that you get that out. Then the rest is really about managing containers when not the other component I want to show around the is about the monitoring tool. So something you can have once you have your mechanism, this is an example of this is running one of my services areas. You can have a JavaScript based front end that is talking to the ICN profile controller. So that you don't only take care about the control plane, the management plane, but also the monitoring plane, so that you can prove the state of the ICN visual state. In this case, what we are monitoring is the state of the channels. For instance, the state of the physical Wi-Fi rate, or the Wi-Fi rate neutral algorithm is tracking channel based on the physical rate based on the channel state. And then what you do here, the same for the Wi-Fi, for the LTE feed. And then the front end is just talking to the local entity and collecting the data with her and the render into web interface. And the other thing we do here is load balancing, so how you're using two channels like LTE and Wi-Fi at the same time, and how the second layer is using them on the state of the time. I think I'm not trying to go into details, but so this is also open source, so you can just download it and use the table, for example, if you want, you can scale. We have used the software also as we do in our World Congress, where we use the storage how to use it. People use the card showing the using the notation of the whole system for showing the videos per second people of the node. Everything is available, so you see in download. As long as you have resources to run the system, you can also run laptops if you want to do something already, but you can scale to any size based on the okay, thank you.
Thank you.
Jay, you have a question? Yeah, let's do one real fast, and then we're going to take a break until 11.
It's actually really nice. I had a quick question for a couple of things. So when you talk about the channel conditions and how you do load balance, be able to say a couple of sentences on that. That's number one. Number two, when you're talking about these large bandwidth data transfers, you're actually the simulation emulation is actually doing real data transfer.
Real time. Yeah. The measurement time, every second we have a sample that we collect from the local water. You don't from the local resource model. But you can develop new resources. Like if you want, for instance, we have caching information. You can get out of the.
My slides.
We're using an algorithm that has been developed a few years ago. It published the ICNP 2013, so it's part of the references. But it's based on it's a Mac. It's a throughput optimal load balancer. So it's trying to optimize the throughput you get out of the channel. But it's not the only possible policy, of course. But that's what we have. Yeah. Well, throughput at a consumer, which is the end-to-end, yes.
So on the test bed, so is that something that is only enabled using containers? Or
you say like if you what is your question? What if I use a VM?
No. I'm just asking is that so test beds are not based on like so I assume they're all based on CICN X1.0, right? So I mean, you could connect any node into this network, or it has to be using this virtual ICN.
Okay, so the question is, can I run a resource outside the container? Is this your question? Yeah, yes. For instance, typically the clients, if you're running, it's hybrid in the sense that you can interconnect to the network an ICM router that is not running a container. It could be an Android device. It could be anything. Well, I mean, as long as you have the right to connect, but yes.
And I mean, I assume you're not using any standard controllers. You're not using any Kubernetes, Docker, OpenDaylight.
We're not using Docker. We're using Linux containers.
But you said use an orchestrator. I mean, what orchestrator?
We developed the orchestrator ourselves, and the software is online. So it's part of the ICN.
So it's not a public domain.
It's public.
No. Orchestrator is not from a well-known orchestrator.
It's from a less known, yeah.
Okay. So I was just wondering, so that's an emulated link system, because the LTE was giving a lot more than Wi-Fi.
So you can use real Wi-Fi and real LTE if you want. We provided this software because, well, the main reason was because I was shocked last year while using real Wi-Fi during Mobile World Congress. So I really wanted to have radio over wire because the Wi-Fi really sucks. And then this is the first reason. Then I told myself maybe it's going to be useful for doing research. and then we publish the code so that you can do your research with the Wi-Fi access. But yeah.
We have the ICN on open air infrastructure.
It works with any real, if you have a real Wi-Fi resource, you put it inside, it works as bad as Wi-Fi works. But what we are providing here is Wi-Fi with a propagation model which are available in NS3. So it's urban, Nakagami propagation model with, all the stuff. So you can have also something meaningful, but, you can do what you want. At least this is controlled, so in terms of collision especially, or interference is controlled, so you can have some repeatable experiments. But yeah, but otherwise you can work anything you want in a controlled environment. Probably for a controlled environment would be better to have something that is more controllable. So, but you can do what you want. As I mentioned open air interface as a project that can also fit into this software.
No, that's why I said it was
Yeah.
Okay, thank you very much. We're going to take a break now and be back 11:15 with the next presentation. And anyone who walked in during the meeting, if you haven't signed a blue sheet, find one. They're lying around somewhere, and sign them during the break. Thank you.
Right. Yeah. So I took some note. I'm not sure I'm professional or not, but
you can put them into the Etherpad?
Okay. No, I don't know.
Yeah, you should type them into the Etherpad. We sent the link around. So look on the wiki.
Okay.
There's a link to the Etherpad, and he wrote them down on paper.
Okay. Can you show me?
So I'm free Wednesday night. That'd be good.